A warm welcome to everyone. I'm Priya, Assistant Professor, Department of Costume Design and Fashion. So in this video, we are going to see about the finishing process, which is the end process of the manufacturing process. Finishing. In textile manufacturing, finishing refers to a set of processes applied to a fabric after weaving or knitting to enhance their appearance, texture, performance, and durability. Finishing can make fabric softer, more water resistant, shrink resistant, flame retardant, and more. It is crucial stages in a textile production that determines the final quality and characteristics of the fabrics. Types of textile finishing processes. First one is mechanical finishing. In that, calendering, the fabric is passed through a heated rollers which smoothens the flattens it, giving it a polished surface. Calendering can also add a slight sheen to the fabric. Next, singeing. The fabric is passed over a flame or a heated plate to remove the surface fibers or a fuzz, resulting in a smoother surface. Next, brushing. A mechanical process where fabrics are brushed to raise the fibers on the surface, creating a softer, fuzzy texture. Next, napping. Similar to brushing but more intense, it raises the surface fibers of a fabric to produce a thicker, warmer texture. Next, embossing. The fabric is passed through engraved rollers to create a raised design or a pattern on a surface. Next is chemical finishing. First one is scouring. This process removes the natural impurities such as wax, oils and pectins from natural fibers like cotton. It enhances the fabric's ability to absorb dyes and finishes. Next, bleaching. The fabric is treated with the chemicals like hydrogen peroxide to remove the natural colors and impurities, resulting in a whiter base for a dyeing or printing. Next, mercerizing. The cotton or other cellulosic based fabrics are treated like a caustic soda solution, which increases their luster, strength and dye affinity. Next, dyeing. Applying color to a fabric using various dyeing techniques depending on the desired effect and fiber type. Next, printing. Application patterns or designs to the fabric. Technique used include screen printing, digital printing and rotary printing. Next, waterproofing. Chemical finishes such as silicone or a fluorocarbon compounds are applied to fabrics to make them water resistant or waterproof. Flame retardant treatment. Chemicals are applied to fabrics to make them resistant to catching fire. This is often used in materials for children's clothing, upholstery and uniforms. Anti-pilling. A treatment applied to reduce the formation of the pills, that is small balls of fibers on the surface of the fabric, which can occur during wear and washing. Antimicrobial and antibacterial finishes. Chemicals are applied to inhibit the growth of bacteria and over microbes, providing odor control and increasing the hygiene of the fabric. Softening. Chemical softeners are applied to the fabrics to enhance their softness and hand feel. This is common in garments like t-shirts and bedding. Stain resistance. Treatments are applied to fabrics to make them more resistant to stains, often used in upholstery and outerwear. Heat setting. Fabrics, particularly those made from synthetic fibers, are subjected to controlled heat to stabilize their dimensions and improve the internal stresses caused by manufacturing process. This process also sets the shape of the fabric, preventing it from the shrinkage or stretching during the subsequent use of washing. Functional finishes, UV protection. Chemicals or finishes are added to the fabrics to provide protection against harmful ultraviolet rays from the sun, This is common in outdoor wear and fabrics used in outdoor settings. Wrinkle resistance, a finish applied to prevent the fabric from wrinkling during usage and after washing. Common in dress shirts, pants and bed linens. Anti-static, finishes that prevents the buildup of static electricity in fabrics, which is particularly useful in synthetic fibers. Application methods. Padding. The fabric is passed through a chemical solution and then squeezed between the rollers to ensure even distribution of the finish. It is called as padding. Spraying. A finish is sprayed onto the fabric, often used for applying the functional finish like water repellency. Next, coating. The fabric is coated with a layer of finishing materials such as PVC or polyurethane to achieve the specific properties like waterproofing. Next, foam finishing. A foam containing the finishing chemicals is applied to the fabric, which is more economical and reduces the use of water and energy. Environmental consideration. Sustainability. Many traditional finishes processes involves the use of water, energy and chemicals, which can have a significant environmental impacts. The industry is increasingly adopting the eco-friendly alternatives such as waterless dyeing techniques, biodegradable chemicals and recycling of processed water. Waste management. Proper handling of waste products from the finishing process such as chemicals and wastewater is essential to minimize the environmental impact. Importance of finishing. So finishing is a vital for ensuring that fabrics meets the functional and aesthetic requirements of end users, whether it's adding softness, durability or a special properties like water resistance or UV protection. Finishing processes helps create fabrics that are fit for purpose and across a wide range of applications. Thank you.